Hello everyone, welcome to the series of filling of electron in an atom. Today we will discuss the electronic configuration. Electronic configuration is a very important part. Before this, we have discussed three main rules, that is Aufbau principle, Pauli's principle, and Hund's rule. These are very important for knowing the electronic configuration. I'll just summarize these three principles. What does Aufbau principle tells? That is n plus L rule. It basically tells the order of energies of orbitals, and Pauli's exclusive principle tells us that no two electrons in a subshell can have same spin. And what does Hund's rule say? The Hunt rule say that pairing of electrons in an orbital belonging to same subshell will take place only when each electron in that subshell has got one electron. I mean, see, so this is electron gets in this shell, electron gets subshell gets one electron, then only the second electron can come. So it cannot come like this, one here and again here and here. This is not correct. This is the right one. First it gets one subshell gets one electron, and then the second electron comes. If you have not watched the previous lectures, you have to watch. They are very short lectures. So let's start uh, today's class. So before going to it, you have to know the Euler's diagram, which we have discussed in the previous lectures itself. So let's get started. So we'll directly write the electronic configuration using previous lectures. So first one we'll be taking firstly we'll be taking fluorine. So the atomic number of fluorine is 9. Fluorine atomic number is, so it has 9 electrons. So first the electron goes into the 1s. So this is 1s, this is 2s, and this is 2p. So first the electron goes into 1s, and in 1s 2 electrons get paired because this is a single subshell. It gets, and by Aufbau principle, this is the energy of orbital. The first principle is satisfied anyhow, and the second principle, that is Pauli's exclusive principle, tells us that no two electrons can have same spin. So we have two different spins, and in 2s we have again two different spins. And while filling in 2p, we have to keep Hund's rule in mind and fill the electrons. And then the second electron comes. So this is the electronic configuration of fluorine. So here you can write, that is 1s2, 2s2. So we'll write it here, 1s2, 2s2, 2p5. So this is the electronic configuration. Let's see for neon. Neon, it's 10, and this would be its electronic configuration. Okay, this all you can do it by your own. It's very easy. Now let's talk about the main part. Those are exceptions. One is chromium, and one is copper. The configuration of chromium is, we'll go into the black screen, and configuration of chromium is AR 4s1 3d5. It basically tells that argon configuration comes before and then this. So this is an exception, so you have to remember this one. Basically the actual one would be, here we will have 4s2 and 5d4, but due to some exceptions we have made it like this, that is 4s1 3d5. So these two are the only exceptions, right? here we have 4s2 and 3d9. So that's all for today. Hope you liked the lecture, and until then, keep studying.